Hey guys, welcome back to another lesson. Today is May the 4th, so May the 4th be with you. Might as well, huh? Like a t-shirt? Pretty cool stuff. But anyway, not what we're talking about today. We're not talking about Newton's laws. Today we're talking about factor by grouping. This is part 2 of the lesson I was showing you previously. Okay, so we factored cubics. Now what we're going to do is we're going to factor just a normal strand of terms right here, a polynomial here, and see what we can do to simplify it. I'll have 2 examples of this, and then I'm going to show you how to solve by using quadratic forming. That'll make more sense later on. Let's jump into it. Let's say I have this lovely expression right here, a lot of stuff going on here, but I want to factor it a little bit. I want to make it a little bit more simplistic, okay? So what I'm going to do is I'm going to take note as to what's in here, and I can see that from here to here, each one of these terms has a common element, and the common element is x. They all have an x in common. And if I look at this second part, I can see that each one of these has a y in common. So because of that, I'm going to go ahead and factor that out for each one. Okay? So let's go ahead and do that. So I'm factoring x out of this guy. Now notice 8, 4, and 4. I could factor out another term, right? I could factor out a common element. Common element there would be a 4. I could factor a 4 out as well. Okay? So out of the first grouping here, I have a 2a. This guy would be a 2b. And then, oh, not 2b, just a b, huh? Sorry. 4 divided by 4 is 1. And then the last one would be just a c. Now over here, let's think about this. I could factor a y out because they all have that in common. They also have a 3 in common, right? So I can factor a 3 out. And notice when I factor this out of the first guy, I get a 2a plus b plus c. Okay? Now, what's very important for you to notice is I have the same term here and here. Okay? They're identical. So what I could do is I could factor out that trinomial. Okay? So let me factor that out. Now notice, when I factor this from here, I'm left with the 4x. And when I factor this out of this second term, I have a 3y, positive 3y. Now if you're ever curious, remember, we did talk about this when we did factoring a long time ago, but if I take this term and multiply it by this entire process right here, this entire trinomial, I get this guy, right? And if I factor 3y to this, I get this guy over here. Factoring is not changing the equation whatsoever. It's not changing your original problem, okay? It's just making it a little bit more simpler to either A, solve, or B, maybe just simplify, okay? I use simplify a lot in this video, sorry about that. So here we go. Now I could multiply both of these together, and I should get the original, and I would. And I highly encourage you to pause the video and do that. Make sure you do get the original, okay? All right, there's our first problem. Let's try another one. All right, let's look at this guy. Uh-oh. Not this, sorry. Let me get this off to the side here. This is actually what we're going to be solving a little bit later. Let me erase the answer, though. Should have erased that before I did that, sorry. Okay, now looking at this guy, I'm going to go ahead and factor by grouping again. What do I have here? Well, notice it's not as pretty as the other one. It was kind of factored nicely for us already. But notice I have a y here, a y here, and a y there. Those 3 items have y's in it, so why not group them together? I'm going to go ahead and rewrite this. So we have 20 fy plus 15gy minus 10hy. I'll group those guys together. And let's look at the other terms. I think the other terms have what? A z in common. So I'm going to go ahead and put those guys together. So we have negative 16fz plus 8hz, say that 10 times fast, and then minus 12gz. There we go. All right, now what are we going to do? Well, same process as before. I'm going to go ahead and factor out a common element. So I know the first one's a y. Now, 20, 15, and 10 all have 5 in common, so I'm going to factor a 5 out as well. Okay? So let's see. For the first term, I'm going to have a 4f. This one, if I take a 5y out, I have a 3g. If I take a 5 out of this guy, I get a minus 2h. Okay? And you can always check your work. Multiply this to the entire trinomial, you get this guy. Now, over here, well, remember, the goal is I want this to show up over here because I want to factor that out when I'm finished. So this will make more sense afterwards. I'm going to factor out, for this guy, I'm going to factor out a negative 4. I think that's what each of the integers has a common element of. And I'm going to factor a z out as well. Okay, so why the negative? Well, here's where it comes into play. This would give me a 4f. This one would give me a minus, what would that be, 2h. And the last one would give me a plus 3g. Okay? Now let's take a look at these guys here. At first glance, you're like, Mr. McCullough, not the same. I'd be saying, no, check again. It is the same. Okay? I just switched these guys. See how these guys are switched over here? They are the identical trinomial. They didn't change whatsoever. Does that make sense? All right? If you want to rewrite it, you can. In fact, we can change this around now if you'd like. So let's do that. We'll put 3g over here. And then we'll do minus 2h over here. Okay? But I just want to be, because here's the deal, guys. When you rearrange the original, you're not going to know how to reorder it to where this comes out perfect each and every time. So on purpose, I wanted to show you that, hey, these are the same. It's okay if they're out of order. All right, let's factor this term out. And then the other one would be 5y minus 4z. These two multiplied together gives me the original. And this is a lot easier to work with. Imagine this, though. Imagine you had this string of values divided by another string of values. I don't want to evaluate that. So by breaking it up into its factors, I could cancel out some of those factors, which could help the simplifying process. What do you think? Pretty cool, huh? Alrighty. Now, if they have nothing in common, if there's no common elements, there's no common factors for the numbers, guess what? We call that prime. We talked about that in the previous video. A prime, it just means you can't factor it. Doesn't mean there's something wrong with the equation. I want to be very clear with that, okay? The equation could be fine. It's just not factored. All right. There's the first part of this video. You ready for the second part? Ready for some interesting mathematics? Here we go. Let's look at this guy. What I'm going to do, okay, is I'm going to solve this by factoring, but not the way that you probably think of it. I have a fourth, a squared, and then I have no x, so there's no x term, okay? And I want to put it in this format. Now, why would I want to do that? Well, let me show you. If I was going to solve this, the only method I have currently right now that would work would be graphing, right? Graph it, see where it crosses the x-axis, and then those are my solutions. But there's an issue with that. Graphing doesn't show imaginary solutions that much, huh? And when it comes to anything bigger than 2 up there for the exponent, it can be kind of difficult to catch that. So what I'm going to do is I'm going to write this in this format, okay? Now, this will make more sense when we get through the entire process. So just hang in there, okay? It'll be okay, I promise. So the first term is the x squared. This is your x term. Now, these have to be the same, right? Just like in the quadratic. This is an x, this is an x. Okay, these got to be the same. So let me break this down. 4 and 8 have a 2 in common, right? So what I'm going to do for this guy is I'm going to put a 2x squared here and a 2x squared here. Okay? So once again, the goal is to make these guys identical. And you'll see why in a moment. This is negative 8x squared. That doesn't match it yet, right? What do I have to multiply this guy by to get that negative 8? Well, it'd be a 4. Over here, x squared raised to the second power is x to the fourth. Good. 2 squared is 4. Is that 4? Yes. I don't have to put nothing outside of here. We're good. This does represent this guy. All right. Once again, if I simplify this, I get the original. I don't change it. Now, what to do? Well, here's what I'm going to suggest. We're going to let a random variable, let's say u, equal the term that they have in common. So the 2x squared. I'm going to let u be that. All right? So anywhere I see this term, I'm going to pluck it out and put u in its place. This would be u squared. And then over here would be minus 4u plus 3 equals 0. Now notice, I took something that was a quartic, all right, and I simplified it down to a quadratic by a little bit of substitution because they have a 2x squared. That's what they have in common. Okay? Now I could solve this by factoring. This is easier to solve. And here's the cool part. The answers to this quadratic are going to be the answers to this quartic. Don't believe me? Stick around for the video. You'll see. Now, let's factor this guy. Factors of 3 that give me negative 4 when I add them. I think it's what? Negative 3 and negative 1? So we get u minus 3, u minus 1 equals 0. Now, to solve this, I'm going to use a zero product property. So set each of these equal to 0. This is going to work out really nice. This is going to be 3, and this guy would be a 1. But I'm not done. All right? Not done yet. There's an issue. These are answers to this guy. They're not answers to this guy yet. This has x's. Now, what was x, again, originally to this guy? Well, look what we substituted. These solutions, I'm going to plug into this substitution, and that will allow me to figure out what the solutions are to this guy. Okay? So now, we're going to sub back what u is. Okay? So let's go ahead and do that. So for this guy, we get 3 equals 2x squared. Then over here, we get 1 equals 2x squared. Okay? Now, down here, divide both sides by 2. I get 3 halves equals x squared. Now, I have an issue already. I'm running out of space. Let me just bring it on the board over here. There we go. Want to make sure it's in. Yeah, we're in sight. Okay. Let me get rid of this previous example. We don't need it anymore. There we go. Okay. So I'm going to bring that down from over here. So we're going to take the square root to both sides. And I can break up the square root if I want to. Okay. And when we take the square root, it's always positive negative of that value. That's my answer. Now, why did I split it apart? Why didn't I just put it under one big giant square root? Technically, you could leave it there, but this would be a great review for rationalization. We haven't done that in a long time. So why not, let's give it a shot. I can't have a square root in the bottom. Here's an easy way to remember this. Think of it this way. A fraction, the denominator is the total. The numerator is part of the total. Well, square root of 2 is irrational. Can you really take something out of another thing that never ends and have a fraction represent it? No, not really. So let's go ahead and make this a little bit better. Okay? So what I'm going to do, the plus and minus I'm going to ignore for right now. I'm going to multiply top and bottom. Oh, sorry. I'm going to multiply top and bottom by square root of 2. I'm going to rationalize it. So the numerator, I get square root of 6. The denominator, square root of 2 times square root of 2 is square root of 4. Take the square root of that, you get 2. So my x value is plus or minus the square root of 6 over 2. Okay? These two answers will make this guy true. What do you think? So far, so good? All right, let's go back to this guy now. Divide both sides by 2. I get a half equals x squared. Do you kind of see what's going to happen already? It's going to be just like this. So let me write it over here. So x is equal to plus or minus 1 over square root of 2. All right. Now we're not going to leave this format, not proper. So let's go ahead, multiply top and bottom by the square root given to us. In the numerator, we get square root of 2. Denominator would be 2. So, oops, I don't know why I did that. X will equal positive negative square root of 2 over 2. These guys are my solutions to here. All right? That's pretty darn wild, right? That's really weird. But it's an effective method. If you have an equation like this and you're not sure how to solve it, break it down into something that you can solve. And we did that by, I'll just move it over. We did that by substitution. Okay? So it's a lot, especially at the very end. We had to rationalize a little bit to make it an acceptable answer out of it. Okay. Let's do one more. One more. One more. One more. All right. So we're going to solve this guy using quadratic form. Okay. And here's my marker. Okay. So we're going to do something very similar. This one's going to be a little bit different because, well, you'll see. All right. So once again, let's put it in this format. Okay. Now, what's a common element or a common factor for 8 and 10? And I think there's only one that's going to work. It's going to be 2. So I'm going to do a 2x squared here for both of them. That's going to be my common term. Now, what I put on the outside, remember, that's just for what this is, right? If I can get it back to the originals. All right, so let's see here. 2x squared times what gives me 10x squared? I think I have to put a 5 there. Now, over here, this works. 2 squared is 4, but that's not quite 8. So I got to multiply it by a 2, and if I simplify that, I get this guy down. Perfect. All right. Now, let's go ahead and do some substitution. Let me just kind of push this a little bit further so we can see the entire board. Okay, so we're going to let u be 2x squared. Okay. Ironically, it came out to be 2x squared again. I didn't mean to put 2 examples with the same thing. Okay, so just be careful. This could be 3x squared. This could be 5x squared. Okay, it doesn't have to be always 2. It just kind of worked out that way. So let's go ahead and rewrite this. We got 2u squared plus 5u minus 12 equals 0. Now, I'm going to try and solve this quadratic by factoring. You could guess and check with factoring here. Because the a value here is bigger than 1, I can't do what I did over here. This is going back to when we did factoring a long time ago. I can't find factors of 3 that give me negative 4. Not going to work. Okay? So instead, I did show you a technique that will work for this, if you don't want to guess and check. You take the first and last term, multiply them together. So we get negative 24. And I want to find factors of negative 24 that give me 5. Okay? That would be 8 and negative 3. Now, to continue, what we do is we take the first term, we rewrite it, then we add in the factors, adding the variable to it as well, and then the last term comes down, set that equal to 0. Now, it's always weird because in mathematics, I want you to be very clear. We're not doing stuff randomly. There's purpose to it. If I add this all together, I get the original. So I didn't change the original equation. I want to be very clear on that. Now we're going to group these guys together. I'll put a little plus sign there. That way you know I'm not changing it. If I add this, I get this. For the first one, I can factor a 2u out. So I get u plus 4. For the next one, I could factor out a negative 3, and I get u plus 4 as well. And hey, look, I have the same binomial. So I can factor that guy out. And then on the other side, I get 2u minus 3. Okay? You're going to see that in the future, a lot of the math stuff that we're going to do is going to I cannot talk for some reason to save my life today. It seems like that's the pattern in every video. I always have a hard time explaining or talking, I should say. But anyway, the further along you get with math, everything builds. We'll say that. Everything builds on each other. So in other words, what you learned a couple years ago might come back into play, or what you learned last year in your algebra geometry class could come back into play this year. So it does seem like a lot, but these are concepts you covered before. Set each one equal to 0. Okay. And for the first one, we get u to be -4. Uh-oh. Let me just adjust the camera. And for the last one, if I solve it, we get u to be 3/2. Okay, you ready for the second part then? Let me just move this up a little bit. Okay, let me bring in the other whiteboard. Let's wrap this up. We're almost done, guys. Hang in there. You're doing just fine. You're doing really good. You're doing really good. Okay, so let's go ahead and plug these back into what our substitution was. Okay, our substitution, if I move this over a little bit, was this guy right here. Okay? So let's go ahead. -4 equals 2x squared. And then my other substitution, sorry, get the camera up here. My other substitution would be 3/2 equals 2x squared. Can't write. There we go. Okay? All right, so for this guy, divide by 2. I get -2 equals x squared. And, oh no! You see what's going to happen to this guy? We're going to get some negative values here, or imaginary values, huh? So imagination. So this is going to be plus or minus the square root of -2. I can factor an I out, right? So this would be plus or minus I square root of 2. This quartic polynomial has 2 imaginary answers. Okay? Now, let's look at this guy over here. Divide by 2, I get 3/4 equals x squared. Take the square root to both sides. Now I'm going to separate it here for a second so you can see what's going to happen. This comes out nice. I don't have to worry about rationalizing like this guy over here, right? I don't have to do that this time. Hooray! So over here we get plus or minus the square root of 3/2 equals x. So this one has 2 real and 2 imaginary answers. Now, if you tried graphing this guy, okay, you would probably be able to estimate these 2 solutions, but you wouldn't get to the 2 imaginary ones that work for this guy. So graphing, where it does have its advantages, does not provide to you all of the necessary solutions to this guy. Okay, does that make sense? So just be careful with that is what I'm trying to tell you. All right? That's it. So this one's a little bit longer, and I apologize because these do take a little bit more time. Hope you're all doing well, and that's it. So, hey, I'll see you all in the next lesson video. Take care.